Okay, section 8.5, modeling with parametric equations. A plane's position at time t seconds after takeoff can be modeled with the following parametric equations. X equals v cos theta t, measured in meters, and y equals v sine theta t, measured in meters. T is obviously greater, I guess can be equal, although they didn't put equal, I don't think, in the book, but time is measured from the start, which is t equals 0. So v is the speed of the plane, theta is the angle of elevation of its path, x is the horizontal distance travelled, and y is the vertical distance travelled. So if this is the plane taking off, can't really sketch the plane, there you go. That is theta, this is x, and this is going to be y direction. So when the plane has travelled 600 meters horizontally, it has climbed 120 meters. So when it's gone 600 across, it has gone up 120 meters. Find the angle of elevation. So for part A, this is simple trigonometric problem. Here is a right angle triangle. The inclination is 120 and the horizontal distance 600. So this is going to be tan theta equals 120 over 600. So theta is equal to arc tan 120 over 600, which is normally in those questions and vectors questions, it will be given in degrees, the angle. So tan inverse of that. Okay, I've got it in radians, so let's quickly convert it. 11.3 degrees to 1 decimal place. So this is the angle of elevation. Now we have for part B, given that the plane's speed is actually v is equal to 50 meters per second, find the parametric equations for the planes of motion. So here's the parametric equation. So x is equal to 50 cos, it's going to be 11.3 times t, and then y is equal to 50 sine 11.3 times t, measured in meters. Now, since you know that the how you found the angle of 11.3, you can actually write down the exact value for sine of that angle and cos. So just in case you do need it, what you want to do in this triangle, you've got a simple triangle. Let's find the hypotenuse by doing 120 squared plus 600 squared and square rooted. It's actually not a very nice angle. Let me just scale that triangle down. So 120, if you scale it down, you get 1 over 5, because you can cancel this by 120. So this is going to be 5 squared plus 1 squared, square rooted, so square root of 26. So in case the question requires you to find the exact value of sine theta, you write as 1 over root 26, and cos theta 5 over root 26. So the equation for x is going to be 50 times 5 over root 26t. So that's 250 over root 26t, and y is going to be 50 times 1 over root 26t, or 50 over root 26t, and let you rationalize the denominator. So these are the equations involved. For part C, we find the vertical height of the plane after 10 seconds. So the vertical height, what is y, when t is equal to 10 seconds. So we are going to put into this equation 50 over root 26, multiply that by 10, so it's 500 over root 26. So it's 500 divided by root 26. That gives me 98.1 meters. For part C, that was part C. For part D, we are asked to show that the plane's motion is a straight line. So to show that it's a straight line, you've got to eliminate t and find the y in terms of x and show that it gives you the linear equation. So at the moment, y is equal to 50 over root 26 times t. So we're going to rearrange the equation for x. So times it by root 26 and divide it by 250. That's the t in terms of x. Substitute it into this equation. You have y is equal to 50 over root 26 times by root 26 over 250x. So y is equal to 1/5 of x, or 0.2x. So it's a straight line passing through the origin with a gradient 0.2. Explain why the domain of t, so t greater than 0, is not realistic. So as with those questions, they work for certain value of t. As time gets longer and more time elapses, as t gets bigger, you will not expect the plane to follow the straight line path and keep on climbing forever. So the plane would not carry on climbing along a straight line with the same speed of 50 meters per second, and maintaining the same angle of elevation. Okay, let's move on to example 12. So with the example 12, we've got a stone that's being thrown from the top of a cliff, which is 25 meters above sea level, or ground level. And here is the path of that stone. It looks like a parabola. So it's being thrown at 45 degrees to the horizontal, and then it curves itself and falls down. The two equations that the path follows are, you've got the horizontal equation, which is a constant function, linear function, and y equation, which is quadratic equation, both obviously in terms of time. So x and y directions are horizontal and vertical directions. So the first thing you notice is that the value of t is reaches k. Now clearly k is going to be where the stone hits the ground, or the sea, whether it's being thrown into the sea or not. So this is what happens here. We are going to be on the ground level. So at this point, y is going to be equal to 0. Now, if we can solve the equation for y equals 0, we'll find two positions, two values of t, because our value is quadratic. The y is described in terms of a quadratic. So one will correspond to this time when it hits the ground, and one will correspond to this parabola starting at ground floor over here, but obviously you can't go back in time. Time would be negative, so we'll reject that answer. So let's solve this equation. So it will hit the ground where you're going to be on ground 0, so y is equal to 0. So let's solve this equation. Now with modeling equations of this nature, you're perfectly fine to use your quadratic solver, which is a polynomial of degree 2 substitute the coefficient. So minus 4.9 is the coefficient of x squared, which is on the calculator by t squared in the question. Then you've got 5 root 2 over 2. So it's going to be 5 root 2, close brackets, divided by 2. And the last coefficient is constant value is 25. So if you press equals, you will get the value of t being 2.648 seconds. And if you press again, you do get minus 1.926. So we are going to reject this one because we can't have negative time, and maybe round it to decimal places, which is 3 significant figures. So it's 2.65. Now we ask for part B to find the horizontal distance traveled by the stone once it hits the floor. So what is the horizontal distance that it covers from the moment it was thrown to the moment it reached that point? So we just need to substitute t into the equation for x. So x is equal to 5 root 2 over 2 times t. So t is equal to 2.65. So this gives me 5 root 2 over 2 times 2.65. So it's going to be 5 root 2 divided by 2 multiplied by 2.648, 9.36 meters rounded to 3 significant figures. So the displacement from the origin is 9.36, and the origin, well, the x, the y equals to 25 and x equals to 0 is the starting position. So moving on to example 13. Here we have a skater, the motion of a figure skater relative to a fixed origin over here. O at time t minutes is modeled by using parametric equations, which are stated over here. Okay, so we are, for part A, we are asked to find the coordinate of the figure skater at the beginning of the motion. So at the beginning of the motion, t is equal to 0 at the start, initially, at the beginning of the motion. So when t is equal to 0, we'll have x is equal to 8 cos 20 times 0, so 0, cos 0 is 1, so it's going to be 8. And y equals 12 sine 10 times by 0 minus pi over 3. So sine minus pi over 3 is going to be minus root 3 over 2. So that gives me minus 6 root 3. So the coordinate of its starting position at the time equals 0 is 8 across minus 6 root 3. So if you look at the diagram, these points are here at 8. So it's got to be this point somewhere here. This must be minus 6 root 3. And that will be 8. Part B, find the coordinates of the point where the figure skater intersects his own path. So he intersects, so he's traveling probably this way, clockwise, could be anti-clockwise direction without checking the values of t. What happens for t equals 1 maybe, not entirely sure. But however, it will reach this point which is on the x-axis, and then we'll come back. Now we are told in the diagram that happens at minus 4. Now, judging by what they've done, we can't assume that it happens at minus 4, but we know that it will, the figure skater intersects his own path on the x-axis, so y is equal to 0. So if I can solve this equation, 12 sine 10t minus pi over 3 equals 0, that should give me I'm going to look for the first two solutions, the first one when it starts, and then the first time it intersects and the second when it comes back onto itself without having to do it again. So 2 consecutive solutions are required. So sine 10t minus pi over 3 is equal to 0 when you divide it by 12, giving me 10t minus pi over 3. That happens at 0, pi. Now if you carry it on, it will be 2 pi, 3 pi, multiples of pi. So we're going to add pi over 3 and then divide by 10. So t is going to be pi over 3 divided by 10. Then you've got add pi over 3 to pi, you will have 4 pi over 3 divided by 10. If you carry it on, you will have 7 pi over 3 divided by 10. And then one more would have been 10 pi over 3 divided by 10. So we've got pi over 30, 4 pi over 30 are the initial ones. There you go. So let's, what was the question? Find, for part B, for the coordinates of the point where the figure skater intersects his own path. So that value of t here is pi over 30, but also 4 pi over 30, which is 2 pi over 15, but kept it as 30. So let's find the coordinates. We already know the y coordinates are 0. So what are the x coordinates? Let's substitute the 2 values into this. So the first one is pi over 30, goes instead of t. So it's 8 cos, it's going to be 20 pi over 30, which is 2 pi over 3. Now, 2 pi over 3 is going to be minus 1. No, 2 pi, hold on, cos 2 pi over 3. That's 120 degrees, so that's going to be minus a half. That's what I was looking for, minus 4. And we can just confirm that you'll get the same value of x. You need to check it when t is equal to 4 pi over 3 over 30. So that's 8 cos, and you've put 20 times 4, so it's 80 pi over 30. So it's 8 cos 8 pi 8 over 3. So it's 2 and 2 pi over 3. So take away 2 pi, that's going to be the same as cos 2 pi over 3, which is the same as the one above, minus 4. Check it on the calculator. So the figure skater intersects his own path at minus 4, 0. Part C, find the coordinates of the point where the path of the figure skater crosses the y-axis. So the y-axis, we're talking about these points over here. So we've got to solve the equation x equals 8 cos 20t. We're going to make it equal to 0. So 8 cos 20t is equal to 0 when cos 20t is equal to 0. Give me 20t is equal to pi over 2. Then you've got 3 pi over 2. You want 4 consecutive answers because there's 4 solutions I'm looking for. So you've got plus or minus because of the symmetry of cos. So t is equal to plus or minus pi over 40 and plus or minus 3 pi over 40. So let's find the values of y. So y is equal to 12 sine 10t minus pi over 3. So for t equals to minus pi over 40, y is going to be 12 sine. If you sub minus pi over 14 to this, you have minus 10 pi over 40 minus pi over 3. So you're going to have minus pi over 4 take away pi over 3. So minus 7 pi over 12. When t is equal to pi over 40, doing the same, you'll have 12 sine, and you will have pi over 4, because that will be positive, minus 3 pi over 4, so it's got minus pi over 12. Can use the calculator in a minute. When t is equal to 3 pi over 40, you're going to have y equals 12 sine. So if you put 3 pi over 40, sub it in, you'll get 3/4 of pi minus pi over 3. So that's going to be 9 minus 4. So it's 5 pi over 12. And the last one, minus 3 pi over 40, will give us 12 sine. So this one here will put minus 3 pi over 4 minus pi over 3. You do it all on the calculator, by the way. So that's going to be minus 9 and minus 4, minus 11 pi over 12. So let's use the calculator now to work these out. You're going to get 12 sine minus 7 pi over 12. Okay, so that gives me, the first one is minus 11.6. That's one of them. If I put minus pi over 12, that gives me minus 3.11 to 3 significant figures. These are the two negatives, so let's hope these will be positive. So we are going to delete it, put 5. That gives me positive 11.6, and this one should be 3.11. So if we put minus 11, that will give me the value of minus, what happened there? Okay, I had to find the mistake. So the mistake was here when I've subbed minus 3 pi over 40 into this, you will have minus 9 and minus 4, so minus 13. So this one is minus 13 pi over 12. So when you put 12 sine minus 13 pi over 12, you do get positive 3.11. So the points are, so this one here is going to be the lowest one, so it's going to be 0, minus 11.6. This one is 0, 3, minus 3.11, then 0, 3.11, and then 0, 11.6. There you go. So any 4 consecutive solutions, by the way, the book goes for 4 positive, still gets the same answer. So the final part in this question over here is the determine how long it takes the figure skater to complete one complete figure of 8. So one complete figure of 8. So let's just find the paper. So if you look at, you could see there that so when does it come back onto itself? So if you just look at the x equation, you could see that if it was cos t, then one period would be 2 pi, and then cos would repeat itself every 2 pi. Because it's multiplied by 20t, if everything happens 20 times as fast. So you have a squashed graph by 20. So you have 20 of those little graphs within 2 pi. So if you divide 2 pi, considering the period of x's, you will have 2 pi divided by 20. Everything is going to be happening 20 times as fast. Now the period of y's Well, think about this graph. If you just had t minus pi over 3, it would be just a sine graph stretched by 12 along the y-axis and shifted pi over 3 going to the right. Now, if you multiply t by 10, that means it's also been squashed 10 times. So how much faster it's happening than the normal sine? 10 times faster. So the period is 2 pi over 10. If you wanted to, alternatively, you could solve that when it's equal to 0 and go for the second solution. When will the first one repeat itself? And the same with the other one. Or look for the maximum, and then from one maximum to the next maximum, see how far apart these stand. But really, just think times by 20, period's been divided by 20, times by 10, period's been divided by 10. So x's repeat themselves every pi over 10, y's every pi over 5. So y's don't repeat themselves as often as x's, so you need to look for the lowest common multiple. So it's going to be pi over 5, because the x's will repeat themselves every pi over 5 as well. So this is how long it will take. Pi over 5 seconds to come back onto himself. Pi over 5. Let's convert it. It's 0.628. Is it seconds? It's minutes, I believe. Meters. T is minutes. So let's change it to seconds. So press the time one. So it's 37 seconds and 42 milliseconds. So round it up to 38 seconds. Milliseconds, not sure how you write it. Okay, so that is the last example on this section. It's followed by exercise 8e, and in fact it was the last exercise of the chapter, and then mixed exercise after that. Enjoy.